Yeah, use the method of Bernoulli equation to solve problems. Okay, and this is the first question we have here. Uh, if you look at the question, when you see question, okay, and you are trying to use particular methods, the first thing for us to do is to correspond that to the standard form of that Bernoulli equation, of that particular method they mentioned. So since we know that Bernoulli differential equation is of the form P of x equals what? Q of x. So this is the first thing you have to do. So we can see it conforms to that y dx, okay, 1 over x y, your p of x here is 1 over x, and then your q of x is s squared, and then y squared, okay, and you've been told that the n must not be equal to what? Must not be equal to 0 or 1, so that confirms it's a Bernoulli equation. If this one is not there, this would have been a linear differential equation, okay. So step one, what do? Divide through by what? By y2. And that will be equal to what? What minus 2 dy dx. Then plus 1 over x. This one is what? Power 1. So 1 minus what? 1 minus 2 equals what? S squared. Then the next thing to do, that will be what? Y minus 2 dy dx plus 1 over x. This will equal to what? Y minus 1. 1 minus 2 is minus 1. And that's equal to what? F2. Call this one equation 1. We're going to use that for the to do substitute, to put a substitution value there. So equation 1. Then the next thing to do is that give this one a letter. Let what? Let v be equal to what? Y minus 1. That's your step 2. Step 2. Okay. Let it be equal to this. Then differentiate that implicitly with respect to what? With respect to x. Okay, and that will be equal to the v dx equal to minus 1 go to the front. Okay, and then y minus 1 minus 1 minus 2, and dy dx. And this will be equal to what? This will be equal to minus y minus 2 dy dx. So that's what we have there. Okay, so what we can do now, can we make this one the subject? Let's make this one the subject. So that will be equal to what? That will be equal to, let's just remove this minus here by multiplying through by minus. So y minus 2 dy dx is equal to what? Minus dv dx. Okay, so we can call this one star. We can call this one double star. So substitute equation star 1 and star 2 into what? Into equation 1. Into equation 1. Okay, so equation 1 now becomes, come back to equation 1, this is it. We have expression for this, okay, which is what? Which is minus dv dx minus dv dx, okay, then plus 1 over x. Then this one is v, that's star 1, that's v equal to what? Equal to x squared. Okay, so now what we have now, this minus there, we can remove it by multiplying through by minus. So we have dv dx minus 1 over x v equal to what? Minus what? Minus x squared. So this is now what? This is linear. This is linear. I'll call this one a, because we need it. This is linear in what? This is linear in v. This is linear in what? In v. You can see v here. You can see v here. So it's linear in v. And once it's linear in v, then we'll solve it in a linear differential equation methods. Okay, so once it's linear, what is the form of linear differential equation? What is the form? The form of linear differential equation is of this. first differential plus p of x y equals what? Equal to q of x. So that's a form of a linear equation. Okay, so that's form of linear equation. Correspond that to that equation E. If we correspond to that, that means my p of x. In this case now, this is linear in V. This one is linear in what? This one is linear in Y. Okay, so if I want to change it and write it in linear in Y, so this will be the V dx plus p of x v equal to what? Q of x. So this is linear. This is a standard form in what? In V. This standard form in what? In Y. This standard form in what? In V. Okay, so correspond this one linear form, this linear differential equation in V to that equation A. Okay, that means the attachment to your V is your P of x. So P of x is equal to what? Is equal to minus 1 over what? Minus 1 over x. Okay, is that clear? Then we can get the integral factor. Get your integral factor. Get the integral factor, and that will be equal to what? That's a formula that is equal to E P of x dx, and that's equal to what? E integral minus 1 over dx, and that will give me E integral over 1 over x is what? Ln what? Ln what? Ln x. And your minus can be outside the integration. You can take this minus outside the integration. Then you have E ln x minus 1. Okay? And from the exponential, there's a rule when you have exponential with ln of a function. Exponential to power of ln will give you the function inside, and that will be equal to what? F of x. So if you have E ln 2x, that will be equal to what? 2x. So exponential to power of ln will be equal to what? To the function inside that ln. So you just have to know that. So here, the integral factor is what? It's just this one, which is what? 1 over what? 1 over x. So that's the integral factor. So we've gotten the integral factor. The general solution. The general solution has a formula. The general solution is equal to, since it's linear in V, so it will be V equal to 1 over integral factor. I know my integral factor. 1 over integral factor. Open bracket. Integral factor times q of x dx plus c. So this is general solution for linear differential equation. Okay, let's make substitution so that we go to v equal to 1 over, my integral factor is what? Is 1 over x. Okay, my integral factor 1 over x times my q of x. My q of x is there. That's x squared, squared, then dx plus c. Okay, so that's that. Then when you have inverse of a fraction, that will just become this integral. This one cancel, the real one here, dx plus c. Don't forget the bracket here. Okay, v equal to what? V equal to this. That will give us what? That will give us this into bracket. Can you do the integration for this, which will be equal to, this is power 1, so plus 1, that's 2, all over what? All over 2. Okay, then plus what? Plus c. So, and don't forget, v as a substitution value. We said v is what? V is equal to y minus 1. If you check the, this is v. So return it back, that will be equal to what? 1 over y. This is v, which is what? 1 over y. So return that back. So we have that, and that's the answer to this question. So the next thing you can do is just to do the expansion if you want to. That will be x3 over 2 plus what? Plus this. Plus this one times this one. That's c, this. Okay? 1 over y. And we want to remove the inverse here. it's possible. You just take the inverse of both sides of the equation. So y will be equal to what? X3 over 2 plus this, and the bracket what? Minus 1.